Okay, so now raise your hand if you know what GIS stands for. Nobody, right? Nope. It stands for Geographic Information Systems, and you might laugh, but it's actually something so important, so fascinating, and most of us take it for granted and we don't even know it's there. Because, yes, I'll explain in a minute. Actually, GIS is so difficult to describe because it's broad, complex, and it changes rapidly. And anyway, so what I did is I cheated and I went to YouTube and I found a cool video with cool graphics from like the 1990s to describe what it is. They look like the 1990s. The video was actually made in like 2010 or something.
A geographic information system uses computers and software to explore the fundamental principle of geography, that location is important in people's lives. GIS is used to inventory, analyze, and manage many aspects of the world. When you flip on a light switch, chances are a GIS helped make sure the electricity was there. If you drive down a highway, chances are a GIS managed the signs along the way. And if you look at a map on the internet, chances are a GIS helped make it possible. A GIS takes the numbers and words from databases and puts them on a map. Much information is tied to a location, and a map shows patterns in the data we might not otherwise see. GIS allows you to use your existing data in new ways. Putting data on a map helps you ask questions like where, why, and how, with locational information in mind. With geographic knowledge, you can make better decisions. With the vast sources of information available today, GIS is a key tool in determining what it all means. GIS can make maps coded by values from the database to help illustrate patterns. For example, to better understand traffic accidents, we might first group collisions by police grid, then as hotspots. Finally, we can show where citations are issued. Another look at the same data can show accident locations over time. GIS provides location-based solutions today for government and industry around the world.
Right, cool. Okay, so back to our slides. So as you can see, Geographic Information System is a computer-based system that is used to store and manipulate information about geographic features, but it's not just like the kind of stuff. So it's everything that we've been talking about in class, meaning elevations and, distances and stuff, like the geography of a place, but also it has layers and layers and layers of information, from pipes to rivers to natural, like mountains. I don't know, I'm trying to think. Also population, density, and income per household, and all these things that you might think, well, how's this related to this class? And the answer is, this is where surveying kind of hits modern times, I guess. Surveying is used traditionally, and we still need people to come measure our property. But in reality, a lot of the times these points that are being taken by the GPSs are being stored in this very complex computer system that allow us to say things like, oh, okay, I want to open a restaurant. Where should I open my restaurant? Well, let me look at this database and figure out, well, clearly I wanted where there is a particular sector of the population that makes a particular amount of money a year. Also, I wanted where there's this much density in the population, but I also don't want to build it in the middle of a floodplain. And I also don't want to build it behind like a deeply forested area. I also want to build it somewhere where I would consider it to be a safe neighborhood. There's all these different things, and they're all in the same, there's multiple databases, but a lot of them have been consolidated over the years, so that this is the kind of stuff that Google Maps uses in a way. you're able to acquire so much information very, very quickly, especially nowadays with Wi-Fi and smartphones, that we take it for granted, and it's really quite powerful. So it's really, and it's everything. Computer hardware, it's the software, it's the input, it's the analysis, and it's the display that allows us to make decisions based on geographic information system. Geographic information, period. The purpose of GIS is to reduce the time and money consuming activities of handling, recording, and researching tons of data related to our land and population. So there has been tons and tons of money spent doing this, and it keeps growing, so it's not going to stop. But the more data we have, the easier it is to use, the more we can do with it. So who can use GIS? So GIS takes many forms. Everybody has used it in one way or another. A lot of stats we get in news, books, and online are possible because of GIS. Like City of Waco or wherever you are has its own GIS access database, which is a little different. It's different than what you find in, say, Google Maps. They have a lot more information that we don't have access to, but a lot of these are public. So you just have to go to a public library or something and use this to look it up, or your university will have a GIS like entry point, I guess. I'm trying to think of the proper word. Okay, so now Google Maps, as I mentioned, has GIS, and surveyors, civil engineers, geographers, dispatchers, epidemiologists use this a lot because they can track the spread of disease based on a number of factors, and therefore they can figure out if something is waterborne, airborne, etc. Actually, this is a great point for me to bring up right now. Your book, when I was reading the textbook for this class a long time ago, at some point, and I'm trying to remember the page, it recommends this book called The Ghost Map, which has since become one of my favorite books ever. I love it because it talks about how before we had powerful microscopes in the middle of the 1800s, and people were dying from cholera and other waterborne diseases, but they didn't even know that there was such a thing as waterborne disease. So they couldn't see the bacteria in the water. They didn't know that that was a thing. So they thought that everything was passed through the air. And therefore they thought that cholera was passed through the air, but it was through the very thorough investigation of a guy by the name John Snow that they were able to determine that even though they couldn't see it, that it was in fact in the water, and therefore lots of people died first, but after they discovered that, lots of people were spared. Anyway, highly recommend that book, The Ghost Map by Steven Johnson. Anyway, so GIS lies in the intersection of remote sensing, database management, cartography, and CAD. So the brief history of GIS is that it began in the mid-18th century with first accurate maps. That's exactly well, this is actually before I was talking about, but so with advances of physics, math, science, and statistics, geographers were able to use data in multiple ways. So GIS began shaping up with the invention of the computer. And in the 1960s, the U.S. worked on developing urban data banks, and this is where the term GIS started to be used. In the 80s, fast technology advances in the computer world allowed for cost of GIS to go down. And storage, remember, storage was a big deal, and it's crazy the amount of storage we have in our phones compared to what we had 10 years ago, 20 years ago, 30 years ago. I mean, 30 years ago. Most people didn't even have computers in their houses. So in the 1990s, GIS started being available to PC users. And now many firms across many disciplines have access to use GIS data for various purposes. So GIS works with thematic layering, which is, so before, you would collect all this data about location and access and roads and water and sewer. Let's say that you're trying to build a hospital. Phone lines, soil types, census data, and you would try to combine those in a meaningful way to make decisions, but it was hard. That's really hard to do. So now with GIS, you actually can use a very powerful computer to combine this data and give you this kind of hybrid map that shows all the data layered on top of each other in a way that means something to you. So it's kind of like, something like this. I mean, this is obviously just an example, but you would have property lines on top of soil conditions, on top of lakes and streams, on top of topography, on top of forestry. And then you could, see the whole picture. So as far as GIS, there's three levels. The first and most like basic level that takes the most energy and power is just data management, the collection and kind of manage. I can't think of a different one. Managing of data. There's just so much data there, and how do you put it down in a significant way is kind of a tough thing. Then analysis. So once you're able to combine certain variables, say population density with crime rates, with graduation rates or something, then you can do a lot of statistical analysis with that to determine if there are patterns. And then you can use those patterns to make predictions. So if I see a pattern happen through, and this is something that a lot of research is based off of. So if you've never had the chance of taking a statistics course or doing actual research, you'll probably get to do it hopefully soon. But if not soon, then at least this is the kind of stuff you do in grad school. I definitely did some of this. And there are many uses. For businesses, they can use it for market analysis and customer analysis and site selection. But you can also use it for as emergency by emergency responders. If you're studying the natural sciences, you can look at natural hazards. You can also look at transportation and economic development and environmental impact and fastest routes to your destination and population statistics and diseases and city planning and geographic distribution of accidents and crimes. It is just fascinating, guys. So, and we really do take it for granted. So just something to think about. So look at my beautiful, useful map. So you can do these cool maps, and there's apps actually that allow you to do this. Not apps as in like an iPhone app, although maybe there are, but like computer applications that allow you to, if you have access to GIS, to combine these into maps and see them in a beautiful way. So this one has wind speed in meters per second by different zip codes, which is, it's an urban decision system. So someone's using this to figure out maybe where the next set of wind turbines is going to go. It's clearly not here. It'll be over here. Or oil industry from 1859 to 1920, where you would have these little markers with the little one, middle one, or big one, mean barrels of oil produced in between those years. And then you can see, oh, okay, it wasn't Texas like I thought. The biggest producer, it was California. So yeah. Or this one, look at this one. This one has county boundaries and CDC contours. Actually, I don't even know what this is. Oh, yes, seismic hazard contour map for South Carolina. So you can see some interesting patterns here as well. Okay, so there are three basic elements of any geographic information system. First, the selected data about the geographic locations. Second, software to manipulate and manage this data. And third, hardware to store, input, and display data. And in terms of data, there are two types. Spatial data, which describes the geographic location of entities, such as zip codes, boundaries, and roads. And also attributes, which actually speak about it's information about the characteristic that describes a feature, like population and household units and number of, I don't know, senior citizens, etc. And there's also two ways of representation. Now, I don't know if you've noticed so far that I'm going kind of fast. Remember, this is an overview of GIS. People can spend a lifetime studying and looking into this, but at least now you know what GIS is. And if you're going to be a civil engineer, this is something you're going to have to work with. So you have to be at least aware, and you'll learn more as you continue down your major. So there's two approaches to representing spatial data. You can use a vector model, where objects in the real world are represented by points and lines. So this is what engineers like. And then there's the raster model, where the areas are subdivided into tiny cells, and objects are represented in corresponding areas. So here's some examples. We like, of course, these coordinates from a Cartesian coordinate system that allow us to see these patterns. Or some other people that are a little more visual, like these raster model where you're using a grid. So let's conclude what we need to know about GIS. Think of GIS as a method of utilizing a database to model everything you know about a species or a treatment, and not just a way to build a map. So GIS is bigger than maps, although maps is a great way of representing GIS data. So you'll learn to model instead of just how to store data. Then let the computer do the work of maintaining databases and analyzing relationships while you think of useful questions. And learn the language of GIS instead of getting caught up in the technology. So these are important things for you as future civil engineers. Share your data, but also be sure it is useful by creating appropriate metadata. So learn to share information and knowledge instead of just raw data that will mean nothing out of context. And that is it. That's it for GIS and for the sequence of videos. Make sure you do read up on GPS and GIS. There's lots of useful information. All right, that's all.